Now, problem 4 on the test was just doing the calculus thing that I taught you, how to do that. And if they give me the equation for the motion x in terms of time, then I can solve for the velocity and the acceleration equations. So the velocity, you remember the velocity, is the derivative of x with respect to time. So if I take the derivative of this equation, remember what you do is the exponent comes in front, and then I lower the exponent by 1. So when I bring the exponent in front, there's already a 5 there, so it's going to become 15t squared. So the first term is 15t squared. Then plus 4t squared, I'm going to, again, bring the 2 in front. So 4 times 2 is 8. And I drop the exponent by 1. So now it's 8t. And the derivative of a constant is 0. I mean, what a derivative represents is it represents a change.
May I have your attention, please? All students taking MCAS should be in the cafeteria now. Thank you.
So what it represents is a change. Well, a constant means it's not changing. So when you take the derivative of a constant, you're going to get 0. So now that represents the v, and I did ask you to solve it at 2 seconds. So we put in the numbers 15t squared plus 8t. I'm not putting in the units, but we know the answer will end up based on this problem. Well, we'll get meters per second. So we're going to put 2 here and 2 here. And let's see, that's 60 plus 16. So that's 76 meters per second. So there's your answer for the velocity. And now the acceleration is the second derivative of the x equation, or the first derivative of the velocity equation. So looking above, I'm now going to take the derivative of this. So I bring the 2 in front, and I get 30t plus, when I take the derivative of 8t, that's a 1. So 8 times 1 is 8. T to the 0 is 1. So you get 8. Putting in the numbers, we're going to get 30 times t plus 8. So that's going to equal 68 meters per second squared. So you can see it's not even that cluttered. There's not a lot of work that I have to write down, as long as you identify the right equations that you're using to solve these problems. So now the next problem, the key to this one is it's showing the second derivative. It says the second derivative of x with respect to time. So think of this d as meaning the derivative of, or the second derivative of in this case, and the bottom d is with respect to time, because you could have derivatives with respect to position or with respect to velocity. It could be with respect to some other variable. So we do know that by definition this is a. So I'm just going to write it as my a equals negative 2.5 x. Now the question, it also is giving me the k in the problem. So the k is 5 newtons per meter. And it says, what's the angular frequency of the harmonic motion? I'm even putting what the variable is that I'm asking for. That's going to be radians per second. So if I look at what I have here, I'm thinking they're giving me a, so maybe I'm going to have to use Newton's second law, because I know that formula has a in it, F equals ma. So I've got a formula that says F equals ma, and I also have the formula that involves k, which says that F equals minus kx. I'll leave the minus in here now because I'm looking up here and they're putting down the a as a minus, so they're probably also factoring that in the solution to the problem. And you could also think of it as, if I were doing this as a force problem, my equation would be, this would be the force that would be on my picture, and anytime, that would be the net force acting on my object, and the net force always equals ma. When we sum up the forces, they equal ma. So if this equals ma, And if that equals, if both of these equal the force, then I know that MA equals minus KX. So I can write MA equals minus KX, and I can replace my A with minus 2.5x, which is nice because I've got an x over there, and if I replace the A here with minus 2.5x, I've reduced the number of variables that I have. So if I do put that in, if I do replace this for A, I like to have my number first, so I'm going to write it, then it's going to be minus 2.5 mx equals minus kx. And you can see that the minuses are going to cancel out, and the x's are going to cancel out, and now I have something solved for k. I have k equals 2.5m. So 2.5 times the mass is going to equal k. Well, if we're looking for omega, remember we have a formula that says omega equals the square root of k over m. So let's see if I write that in and see if I can solve it like that. So I'm going to get omega equals the square root of k over m. And I'm going to replace k with 2.5m. So 2.5m divided by m. You can see the m's cancel out. So the angular frequency is going to just equal the square root of 2.5 as a number. Now the units are going to be radians per second, but let's see, the square root of 2.5 is 1.58 radians per second. And that's it. And every one of these problems we did as an assignment problem prior to the time that it was on this test. So, and I told you exactly which ones to prepare for.